Hello guys, so we are going to continue the discussion with respect to statistics. Now we are going to start different statistical analysis and we will be doing hypothesis testing. This will be super important as a data analyst, as a data scientist, whenever you probably take up a problem statement and you want to perform different kind of hypothesis testing. Now with respect to statistical analysis, there are various types. One is something called as Z-test. The second one is something called as T-test, right? Then we have something like chi-square test. We have something called as chi-square test, right? Chi-square test. Similarly, we also have ANOVA test, and there are many more tests as such, right? And which we will be discussing as we go ahead, right? Fourth is something related to ANOVA test, okay? Now in all this test, right, this both Z-test and T-test are specifically with respect to data that are dealing with average data, right? Sample average, population average. It will help us to find out with respect to the population. If I talk about chi-square test, this is specifically used for doing statistical analysis for categorical data. And ANOVA test is specifically for variance of the data, right? So all these things we will be using, and over here we will be trying to estimate a population parameter, a known population parameter, and we'll try to see just with the sample data, can we come up with some conclusion regarding the population data. Now in Z-test and T-test, we specifically use two tables, that is called as Z-table, which we have already discussed, and there is also one more table called as T-table. So in Z-table, we specifically try to find out the Z-score value and the p-value. Similarly, in the case of T-table, we will also try to find out the Z-score and p-value. But what is the exact difference between Z-test and T-test? We will try to understand that. Now in this video, we are going to focus on a problem statement that is related to Z-test. One thing that you need to know about Z-test is that whenever, number one, right, whenever your population data, let's say your population average, right, or your population mean, I'll not say population mean, let me just write it down. Whenever you want to use Z-test, the first thing is that you really need to know your population standard deviation. And the second thing, your sample size should be greater than or equal to 30. If these two conditions are matching, then probably you can actually use Z-test, okay? Whenever in any of your data set, let's say if a problem statement is given where you know the population standard deviation and the sample size, where your sample size is specifically greater than or equal to 30, at that point of time, you can basically use Z-test. Now let's solve a problem statement, and over here we will be doing multiple things. We will try to understand about the Z-test as such, okay? So without wasting any time, let's go ahead and let's try to do this, okay? Now, let's read the question first of all. The average height of all the residents in a city is 168 centimeter. So over here, the average height of a resident in a city is given as 168 centimeter. So my question, my first data that I have is that I know the population mean. Here, the population mean is 168 centimeters. Okay. 168 centimeter. Now let's go to the next question. With a standard deviation of 3.9. Now when I say with a standard deviation, this is nothing but population standard deviation. Now since population standard deviation is given, and if I have one more condition when n is greater than or equal to 30, I will probably be using Z-test, okay? A doctor believes the mean to be different. So this is the hypothesis testing that we really need to find out whether the mean is matching the population mean or not, considering a sample of data, okay? He measured the height of 36 individuals. So my sample size is 36, which is greater than or equal to 30. So that is the reason we are using that test, and found the average height to be x bar 169.5 centimeter. Now the first statement with respect to the hypothesis testing is that state null and the alternate hypothesis. And second question is that at a 95% confidence interval, is there enough evidence to reject the null hypothesis? Okay, so this is what we are going to check. And over here, your confidence interval is 0.95, that is 95%. With the help of confidence interval, we can calculate my significance value. All I'll do, 1 minus Ci, it is nothing but 1 minus 0.95, which is nothing but 0.05. So 0.05 is my significance value. Okay, 0.05 is my significance value. Now let's go ahead and solve this both the problem statement, and let's see how we can do it with the help of Z-test and how we can refer the Z-table and everything we'll try to see. The first step in the hypothesis testing is that your null hypothesis. What is your null hypothesis in this case? It is very much simple. What is the basic assumption that is given in the problem statement? The average height of all the residents in the city is 168 centimeters. So I will say my mean is nothing but, mean of the height is nothing but 168 centimeters. Now coming to the next step, which is called as alternate hypothesis. We need to also specify our alternate hypothesis. My alternate hypothesis is H1, and here my H1 is basically saying the reverse of null hypothesis. It will be the inversion of null hypothesis. So we are going to check whether my mean is not equal to 168 centimeter. Okay. Now we will try to test this null hypothesis with the help of statistical analysis. The third step is that based on confidence interval, what we will do, based on confidence interval, we will draw a decision boundary. We will draw decision boundary, right? Now how to draw this decision boundary, that is super important topic. We know what is our mean. Our mean is nothing but 168 centimeter. Now with respect to the decision boundary, we know that, right, in a normal distribution, what is the area within the first standard deviation, what is the area between the second standard deviation. Now what is the confidence interval that we are probably trying to consider is 95%. So 95% if I say from both the scenario. Why I am saying both the scenario? Because this is a two-tailed test. Why I am saying as a two-tailed test? Understand what is the null hypothesis. Null hypothesis is mean is equal to 168 centimeter. And alternate is mean is not equal to 168 centimeter. So what I am testing for is that whether my sample height is greater than or is less than 168 centimeter. So we are checking in both the direction. And based on this both the direction, we are checking it for 95% confidence interval. Right? When I say 95% of the area is probably over here, then the remaining area, if we try to divide in the two extreme ends, it will be nothing but this area will be 0.025 and this area will be 0.025. Okay. So this is the area that we are probably testing. Now what we'll do based on the statistical analysis, let's say if we get any value that is within this confidence interval, then we will consider that the null hypothesis is accepted. Right? We fail to reject the null hypothesis. This is what the statement we specifically say. Okay. We fail to reject the null hypothesis. But from our statistical analysis, if we are falling in this specific area, then we will say that we have to reject the null hypothesis. Okay. This is what we are going to do. Now, with respect to this 95% confidence interval, we need to define this z-score value. Okay. Now, in order to define this z-score value, we need to see that how much area is basically present over here, 0.025. Right? And over here it is 0.025. Let's calculate the z-score for this one. Okay. Let's calculate the z-score for this one. Whatever z-score we will get, since this is a symmetrical distribution, then the same negative z-score will come over here. Okay. Now, in order to find this, you will be seeing this entire area is 1. And in order to find only this z-score, what I will do is that I will subtract 1 minus 0.025. 1, the entire area, and 0.025 is this area. So I will probably be getting this z-score value, which will determine the area under this entire curve. Okay. So over here you will be seeing 0.9750 is my entire area. Right. Now with respect to this, what is my equivalent z-score I need to compute? Okay. It is very much simple to compute based on the area under the curve. This is basically my entire area. This is my area. And based on this, my z-score, we will try to refer it to this particular table. Okay. This table is again Z table. You can just search for Z table PDF. Okay. And just go over here. Now try to see this data that you see, right? This is basically the area under the curve. Okay. Now right now my area under the curve is 0.9750. So go and see for it. 0.9750. We have to see in the positive Z table where my all positive standard deviation are there, because 97% of the entire area we are trying to check. So if you probably go and see over here, there will be one value which is 0.9750. See over here, 0.9750. And based on this, what is my z-score that I'm getting? I'm getting 1.9. And if I see for this particular table, it is 6. So 1.96 is the z-score for this area under the curve, right? So I will go back again over here. Okay, I will go back over here. And now my z-score will be nothing but it will be plus 1.96 for this region. for this region. And after this, you will be seeing that whenever we try to see the left part, okay, whenever we try to see the left part, in the left part, what do you think we will be having? What do you think we'll be having? It is very simple. We will get minus 1.96. Now, any value from the statistical analysis, if it comes between this range of z-score, we will consider it as that the null hypothesis is true. So we fail to reject the null hypothesis. Let's say from the statistical analysis that we do, if it comes in this end, this extreme end, then we have to reject the null hypothesis. So I hope you are able to understand with respect to the decision boundary and all. And you know your alpha value also. Alpha value is nothing but 0.05, and that is the reason we are basically using 95% confidence interval. So this is nothing but, this is my 2.5% of area. This is my 2.5% of area. Okay. Now what conclusion I will try to make with respect to this 1.96 and plus 1.96. The new Z value, let's say the new Z score based on the data, if it is less than minus 1.96 or greater than plus 1.96, we have to reject the null hypothesis. Otherwise, we accept the null hypothesis, right? So this is what we really need to compute. Now, how this Z will get calculated? This Z will be getting calculated from the statistical analysis. Very much simple. So let's go ahead and let's compute it. Okay. So my next step is basically my Z test that I'm going to perform. Okay. Now, in order to perform this Z test based on the data, I'll write Z of t. It is nothing but x bar minus mu. My mu is my population mean with respect to this height, divided by population standard deviation by root n. Now you may be thinking why this we are using, because the z-score formula that we learned till now was something like this, x bar minus mu divided by standard deviation. But understand, this was for the population data. According to central limit theorem, if I'm using it for sample data, my sigma will get changed to sigma by root n. So that is the reason I'm writing this. If you don't remember, guys, just revise the central limit theorem video. In that sample distribution, my mean will be equal to the population mean, but my standard deviation will be nothing but sigma by root n. Now we will go and solve this problem. I know what is my x bar. My x bar is 169.5 centimeter. My mu is 168 centimeter. My sigma is 3.9 divided by root 36. So if I probably do this calculation, it will come somewhere around 1.5 divided by 0.65, which is nothing but 2.31. Now see, what is my Z value coming? Z of D, right? It is 2.39. We have written the conclusion. If Z is less than 1.96, minus 1.96 or greater than plus 1.96, we reject the null hypothesis. Is 2.31 greater than 1.96? Yes. So it is basically coming to the extreme end, right? Now, since it is coming to the extreme end, what do? We basically write 2.39 is greater than 1.96. So what we do? We reject the null hypothesis, right? So this is what is my conclusion, right? So we are rejecting the null hypothesis. So we can definitely confirm my p value is less than 0.05, which is my significance value. But still, I did not get this p value. How do I compute this p value? Now we know that initially my Z confidence interval was between plus 1.96 and minus 1.96, right? So I will go and take up this 2.31 and construct my new graph. Okay. So this is my 1.96 and this is my 2.31 and this is my 2.31. This will be negative. This will be positive. Now this is what I'm getting with respect to my new calculation. It was not 1.96. Okay. Now, based on this, let's calculate the area under this curve till 2.31. So all I have to do is that again go back to my Z table and probably check what is 2.31. Okay. So quickly I will go and see over here. So 2.31. So let's see, this is 2.3 and this is 1, right? So I am getting 0.98956. So I'll go over here. This entire area that you are probably seeing, it is nothing but 0.98956. I guess this is correct. Okay. Right. This is the entire area. But what about this area that I want to get? And that is how I'm going to calculate my p-value, right? So in order to calculate this, all I will be doing is that I will be subtracting 1 minus 0.98956. Now, if I subtract this 1.98956, here I'm going to get somewhere around, if I probably subtract it, let's open the calculator over here. Let's open the calculator. So over here I have my calculator. So I'm saying 1 minus 0.98956. So I'm getting 0.01044. So this area that you'll be seeing, it is nothing but if I see the calculator again, 0.01044. Now this area is equivalent to this area. So this area will also be coming as 0.01044. And the remaining area, if I probably take this entire one, right? Entire one. So it will be nothing but this plus this subtract by 1, right? So if I probably say this plus this subtracted by 1, okay? So how much I'm going to get? So this is nothing but 0.97912, right? So this is what is the area under the curve, and this is the area from this particular left direction and right direction, right? On the left extreme and the right extreme. Now, in order to calculate the p-value, see there are two ways. One is from z-score, which we have done it over here, and one is from p-value, right? Now my p-value is basically calculated by adding up these two regions. So it is nothing but 0.01044 plus 0.01044. So here you will be seeing 0.02088. Now we will go and check whether my p-value over here, whether my p-value is less than 0.05. So obviously 0.02088 is less than 0.05. So what do we conclude? We really need to reject the null hypothesis. What was the null hypothesis? That the mean is equal to 168 centimeters, right? But from the sample data doctor has collected, see, this is the assumed information. Doctor is trying to verify from the sample information. So doctor, if he has collected 36 individuals and the height was 169.5 centimeter with 95% of confidence interval, it is rejecting saying that the mean was 168 centimeters. So over here, you can basically conclude that we are rejecting the null hypothesis, and final conclusion will be that the average height is not equal to 168 centimeters. This is what we are concluding. Okay. But if you want more refined conclusion, since we are getting in the positive direction, that basically means my height is increasing, right? So based on the doctor, the average height seems to be increasing. Average height seems to be increasing based on sample data. This is what is the conclusion that I can definitely make. Sample height, right? So this is what is the conclusion that I have done. This was the first step where we specifically did with the z-test, and this was how we can probably come up with p-value also. Okay. So this is how you probably solve a z-test problem. One very important information about z-test is that whenever you want to apply z-test, this usually gets applied for average data, okay, with respect to population data. You need two information. One is population data, and your sample size should be greater than or equal to 30. Both this problem statement satisfies this. So I am specifically using this. With the help of z-test, and this is my statistical analysis. This is the formula that I have applied. I got my 2.31 as my standard deviation, and based on this, what we did, we calculated our p-value. P-value is nothing but what is the area under this, what is the area under this. We are summing it up, and if this both the sum is less than or equal to 0.05, we will basically say this as that we are rejecting the null hypothesis. If my p-value was coming which was greater than 0.05, we say that the null hypothesis is accepted. We fail to reject the null hypothesis. At that point of time, we could say that the mean is 168 centimeters. So I hope you got an idea about this. We'll solve one more problem so that you'll be able to understand. But just try to solve this problem based on your understanding first of all. Pause the video and try to see whether you are able to solve it or not. Okay. So I will go ahead and explain you till now. Okay. Till then, just pause, try it out, and then let me know in the discussion forum. I will be solving this problem for you. So over here, a factory manufactures bulb with an average warranty of 5 years and with a standard deviation of 0.50. So what is the information that I'm able to get? My mean is 5. Okay. My standard deviation is 0.50. If standard deviation is 0.50 and my sample is greater than 30, then we have to use Z test. So over here, N is nothing but 40. See, he tests a sample of 40 bulbs, sorry. So my N value is greater than 30. So I'm definitely going to use this Z test. A worker believes, let's continue the statement. A worker believes that the bulb will malfunction in less than 5 years. Okay. So it is basically saying less than 5 years. It is not saying not equal to 5 years, less than 5 years. Okay. In the previous problem, my mean was not equal to 168 centimeter in the alternate hypothesis. This is the test that the doctor was doing. So we said it as two-tail test because my mean can be greater than 168. It can also be less than 168. Okay. But in this scenario, you will be seeing that the bulb will malfunction in less than 5 years. He tests a sample of 40 bulb and find the average time to be 4.8 years. So what is my X bar? It is nothing but 4.8. And what is my N size? 40. That is given. Okay. Now, as usual, first statement is that state your null and the alternate hypothesis. So my null hypothesis will be H0. My mean is equal to 5. Okay. This is what is my null hypothesis. What is my alternate hypothesis? Now my alternate hypothesis will be, what is the test happening for? See over here, if I probably go and see, a worker believes that a bulb will get manufactured in bulb will malfunction in less than 5 years. I will just write this as in, okay, in less than 5 years. In less than 5 years. So we are checking only less than 5 years, not greater than 5 years. So my alternate hypothesis will be mu is less than 5 years. Okay. Now with respect to this, you know that this will become only one tail test because we are only seeing on the left hand side, not on the right hand side. So this becomes a one tail test. Okay. Now we'll try to solve this problem. Okay. So over here, you'll be seeing that my next step will be creating a decision boundary because I need to specify my confidence interval. So guys, now we have understood about the null and the alternate hypothesis. Now let's go ahead and understand what decision boundary. Now in decision boundary, as we have already discussed, this is a one tail test, right? So my mean is 5 over here and I want to check my alternate hypothesis less than 5, right? Somewhere over here, less than 5, considering 98% confidence interval, and this is 0.02, that is 2% of confidence interval, right? 2% of confidence interval. I have to only check for this specific area, right? This area. So how do I do this? Okay. The next step will be, I will perform a Z test. In the Z test, we will try to calculate the Z of D value. I'm giving some notation over here. The formula is X bar minus mu divided by standard deviation divided by root n. So here, X bar, what is X bar? 4.8 and then N is 40 and standard deviation is 0.50. Okay. So here I'm going to write 4.8 minus 5.50 divided by root of 40. So if you do this entire calculation, you are going to get minus 2.53. So based on this, the value that you are probably getting over here is nothing but, if I probably consider here, I'm not use only Z test. I will try to directly do with p value. Okay. So that my calculation will be faster. Now with respect to minus 2.53, I will try to find out what is the area under this. Okay. What is the area that I'm probably going to get? And based on that, I'm going to compare my p value. Okay. So minus 2.53, I will go to my Z table, minus 2.53, right? So this is 3. No, not this. This is 3. It is nothing but 0.99430 area under the curve. Okay. Area under the curve with respect to plus value. So if I'm probably considering over here, let's say, but I have got minus 2.53. Okay. So what I will do, I will go and check for this. See, in the negative direction, minus 2.53. It is nothing but 0.00570. This is what area under the curve is, right? So here, what I'm going to do, I'm going to get my entire area under the curve over here with this Z score value. So area under the curve with Z score minus 2.53. I'm going to probably get how much value? I'm going to get 0.00570. Area under the curve with Z score is minus 2.53 is 0.00570. This is nothing but my P value. So my P value is nothing but 0.0570. Now we need to compare whether P value is greater or equal or less than the significance value. So compare P value with significance value. My significance value is obviously 0.02. So if I go ahead and compare 0.07570, whether this is less than 0.02, so this will basically be false because it is greater, right? So in this scenario, since it is greater than false, since it is greater than 0.02, that basically means it is falling in this 98% confidence interval, right? So this is my acceptance area. This is my rejection area. So we are definitely saying that my P value does not fall in this rejection area. Okay. So we are telling that, okay, it falls in the acceptance area. Why? Because my P value is not less than 0.02, which is my significance value, which is defined by this confidence interval. Okay. So what we do, we specifically say we accept the null hypothesis. We accept the null hypothesis. Or we can also say we fail to reject the null hypothesis. Why? Because it is falling in the confidence interval region. Null hypothesis. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video with the new test, which is called as T.